Who asked for this, so I do it. Let's go quickly, or try to do this quickly. Ellie randomly picks a card from the deck. What is the probability that the card is an even number? So my even numbers are 6, 8, and 2, or obviously 3 over 9, or 1 over 3. If Ellie replaces the card and mixes them up and picks a card, what's the probability that the card is an even number? So she took the first card, she puts it back. It's still 3 over 9 because the total hasn't changed, right? Or again, 1 over a third. Now, C says she picks an even number from the stack, keeps it. So let's say she took an 8, keeps it, and then she wants to go back and select another card. What's the probability that the second card is even number? Well, the probability that the second card is an even number, well, notice that there are only 2 even numbers now, and the total 8, or 1 over 4. Okay? So what's the difference between replacing the first card and not replacing a second card? Replacing the first card. If you replace, then the total does not change. Right? The total, actually nothing changes, right? If you replace it. And if you don't replace, then you will have one less of whatever category, the even numbers, the vowels, the consonant, one less of that category, and obviously, and one less in your total. Okay? And then think about the words independent and dependent. What did those words mean to you? Well, I always use the example of, like, I guess at my age, I am an independent person. Right? I don't depend on my mom to feed me or to give me money to go buy things. So I'm an independent person. Okay? I can do things by myself. I do not rely on others. That's what it means to me. And then dependent, obviously, you definitely need or you rely on someone else. Okay. When Ellie picked 2 cards and replaced the first card, was that independent or dependent? Well, that's independent because by replacing the card and putting it back, okay, because by replacing the card, the total did not change, and whatever card she picked also didn't affect that particular category. Okay, I'm just going to leave it at that. Okay, when Ellie picked 2 cards and then replaced the first card, what was that, an independent or dependent? Well, definitely dependent, right, because there was one less even number and obviously one less in the total, right? So that did affect the first event had a role on the second event. Okay. One second, guys. So where are we on number? Okay, so Miss Little, so this created a little bit of a problem in class, right? I messed up. So let's see if I can fix this. What's the probability she picks a girl? She wants to pick a girl. Probability of picking a girl is 10 out of 18 or 5 or 9. Probability she picks a boy, it's 8 over 18 or 4 out of 9, right? What's the so she had Miss Little has student's name on a popsicle stick. What is the probability she picks a girl Monday, puts stick back, not stuck, puts a stick back, and then picks a girl on Tuesday. On Monday, the probability of picking a girl is 10 out of 18. And then she takes that popsicle stick and puts it back. So is it possible she can pick the same girl on Tuesday? Yes, because her name is back on the cup. So 10 out of 18 again. or 5 out of 9 times 5 out of 9, 25 out of 81. Okay. What's the probability she picks a girl on Monday, does not replace, and then picks a girl on Tuesday? Okay, now different story. Probability of picking a girl on Monday is going to be 10 out of 18, right? And then let's say she picks Grace, and her Grace is left out, doesn't put Grace back in the cup. So when you go back on Tuesday, there are 9 girls on that cup. And obviously there's one less in the total, which is 9 out of 17. So what is that? 5 out of 9 times 9 over 17, 45, 3, 153. What's the probability that she picks 2 boys in a row if the popsicle stick is replaced? Okay, so the probability of picking a boy on the first date is 8 out of 18. And if you put the popsicle stick back, then on the second date, there's still 8 boys and there's still 18. Okay, and I'll let you guys multiply that, or 4 out of 9. Oh, that's easy. 4 out of 9, 4 out of 9, which is 16 out of 81. Okay. What's the probability she picks a boy 2 days in a row? If it's not, so it would be 8 out of 18 on the first day. And it should, let's say she picks Thomas. So Thomas will be, his name will be out of the cup. Going back on the second day, he's not going to be in there, so there's definitely going to be 7 boys now. And the total is going to be 17. Okay, and then you multiply that. Let's see, again, 4 out of 9 times 7 out of 17 equals 28, 63, 6, 153. Okay, which of the independents in these situations are independent, and how do I know? Independents are the one where she replaced. So E was independent and C was independent. I know it's not. I know they're independent because the total didn't change, right? And the number of girls were the same on Monday and Tuesday. Okay. And obviously, backwards, the dependent one were the questions where she did not replace the sticks, which was F, and E and F. Okay, not replace. Sorry, F and D, D and F. Okay. And again, why? Because the total changed, right? And there was one less boy, okay, for the second day. Lily's playing a game of cards. In order to win the game, she must pull 2 of the same cards in a row, okay? What's the best chance? Should she replace the first card she picks, or should she keep it? Well, she definitely should replace it, right? So let's say you want to pick, from a deck of cards, you want to pick the King of Hearts. Well, let's not make the King of Hearts. Let's make it a heart. The probability of getting a heart on the first is 13 out of 52. Right? So if she doesn't replace it, and let me put a heart out here, right? If you go back to the deck and takes a second card, there's going to be 12 out of 51. Notice that there are less cards. Well, there's less hearts, first of all, right? So your chances are a little bit less. So you definitely want to replace it, because it would be 13 out of 52 times 13 out of 52. And you can multiply these two, right? So this is actually 1/4 times 1/4, which is 1 out of 16. And this one, 1/4 times. So let me multiply 1/4 times 12 out of 52. 51, I'm sorry. And that's, oh, you can simplify this. Enter, and become 1 out of 17. So definitely you can tell that you have a higher chance here than here. In a cage at the San Diego Zoo, there are 3 black cats. If 2 cats escape from the cage, what's the probability that both cats are black? Well, 3 black, so that's 3 plus 4, 7, 8, 9. 9 cats, and the probability of the first cat being a black cat is 3 out of 9. So let me put the black cat over here. The first cat escaped. And then what's the probability that the second cat that escaped is also black? Well, one of the black cats already gone. So you go back here, there's not 3 black cats anymore, there's only 2. So there's 2 black cats, and what's the total now? 8. So that's 1/3 times 1/4 equals 112. Now we have randomly selects one Skittle, randomly selects a second Skittle. What's probably the first was yellow and second was green. All right. So let me just write 7 blue, 9 purple, 5 yellow, 4 green. So I always start with a total. 9, 18, 18, and 25 total. So what's the probability of getting a yellow? The yellow one was 5 out of 25 first, right? She eats 5, so now she eats 1. So now there's no more 5, there's 4. And the second Skittle she wants is a green. Well, there are 4 greens out of, and the total now is 24. And you guys can multiply that and find the answer. Dependent or independent, what's the probability that flips a coin, a heads, you're going to get a heads and then roll a 6. So it's going to be 1 out of 12, and this is independent, right? Because the total didn't change on the second, what do you call? The first event had nothing to do with the second event. It didn't affect the second event, right? It's not like the dice all of a sudden has 5 sides. It still has 6 sides, okay? And the 6, there's only one side of the dice, of the die that is a 6, so nothing changed, okay? So this is definitely independent. Bag of marbles, green, blue, and red. That's probably that she pulls a green, puts in the pocket, and then pulls another green. Well, definitely dependent, right? Because the total is going to change, the number of greens are going to change. So okay, so we want 5 out of 10 is probably getting a green on the first try, and then there's going to be on the second try when you go for it, it's only going to be 4 green out of 9. And again, you guys can do your multiplication. Drops a coin in a staircase with 5 stairs. What's the probability to land coins on the second stair tails up? Well, what's the probability? So this one is independent. What's the probability of the coin landing on tails? Half. What's the probability of the landing on the second stair? Right? There's 5 stairs, and let's just probability of landing on the second stair is 1 out of 5, right? There's a 1 out of 5 chance that she lands on that stair, number 2. So socks. She closes her eyes, randomly picks 2 socks. What's the probability that both socks are gray? Well, again, dependent. What's the probability that, what do you call, it's gray on the first try? Well, 3 out of 8, 9, 13, 3 out of 13. So let's say she takes a gray, puts it here, and goes back to the drawer. There's no 3 grays anymore. There are 2 grays, and your total has definitely changed. It's now 12, right? So that definitely dependent. So you notice that the total definitely changed. So the first event played a role in the second row, in the second event. Well, the fruit, you want to get oranges. So they want to grab 2 oranges. So there are a total 9. The probability of getting an orange in the first try is 2 out of 9. And then you pick an orange, you go back and try to get another orange. It's going to be 1 out of 8. So this is going to be definitely dependent. And again, you guys can figure out the rest. 27 students. 13 are juniors, 14 are seniors. Probably the first student is a senior and the second is a junior. And again, this is dependent. Let's see why. So the probability of picking a senior. Well, there are 20, so what's the total? 27. And the probability of getting a senior is 14 out of 27. So here's your senior. We picked a senior. So there are no longer 14 seniors, but there's 13 seniors. So we go back to the hat, and we want to pick another name. Well, first of all, we don't have 27 people anymore. We have 26. And what's the probability of getting a junior? Well, the probability of getting a junior is 13 out of 26, or a half. And you guys can multiply. Alexa, stop. And you guys can, what do you call, multiply this. And notice that the total did change. So the first event definitely played a role in the second event. So dependent. Probability makes a free throw is 60%. What's the probability that he makes 2 free throws in a row? Well, those of you who play basketball, this is definitely independent. Just because you made your first doesn't mean you're going to make your second, right? So what's the probability of making the first free throw? Well, I'm going to change to a decimal, 0.6. And what's the probability of him making the second throw? Well, it's also 0.6. Okay, so you guys can find the answer. Two spinners respond at the same time. It's the probability the spinner will land on red, and then will land on red. The probability of landing on red is 1 out of 5 here. And landing on 1 is going to be 1 out of 8. So 1 out of 40. And this is independent. Okay, so I'll write I for independent, right? Nothing changed, right? The total is still the same. It's because, right? Baseball player makes 3 out of 4 at bats. So we can write 3 out of 4. So the probability of him hitting a ball in the first try is 3 out of 4, 75%. What's the probability he get it on this? He hits a ball on the second at bat. Well, it's still 3 out of 4. And we go 9 over 16, and whatever that is, it is. Okay, basketball player, what's the probability he makes 2 shots in a row? What's the probability he makes the first shot? Well, based on this, on the stats that we have throughout the season, he took 15 shots, and so far so the probability of making the shot in the first try is 9 out of 15. And the probability of making the shot in the second try is also 9 out of 15. Okay. 30 tickets are sold for a raffle with 2 prizes. You bought 2 tickets. What's the probability you win both prizes? Well, first prize, let's call it, I don't know, it's a car. And second prize is a vacation. And you're holding 2 tickets in your hand. Well, so for the first prize, the car, you have a 2 out of 30 chance of winning, right? Let's say they call your ticket. Here's your ticket. You hand that in, right? The ticket, you hand that in. So how many tickets do you have when they call out the second prize? Well, you're only holding 1. And how many tickets are in that bag or that thing that spins? Well, there are 29 tickets. So the chances of you winning first prize, second prize is whatever this is. Okay. $13. 16 and 14 girls and 16 boys. 2 students are absent. What's the probability that both are boys? Well, 16 and 14. The probability of a boy being absent, the first boy being absent, is 16 out of 30. So let's say Nick is absent. We want to calculate the probability the second boy is absent. Well, it can't be Nick again. So now there's 29. And how many boys? 15. And then you find out the probability of that happening and multiply. Number of cubes rolled 3 times. What's the probability that a number greater than 4 is rolled all 3 times? Well, a number greater than number 4 is 5 and 6. So the probability of that happening on the first cube is 2 out of 6. On the second cube, it's 2 out of 6, or the second row is 2 out of 6. And the third one is 2 out of 6. Notice that the first event had no effect on the second, and the second had no effect on the third, just because, right? Nothing changed. All the totals are there. The 5 and 6 are still there. It's not like we take one out from the die. A jar contains 6 blue, 4 red, 2 green marbles. What's the probability that 3 blue marbles are drawn without replacement? Okay, so first of all, let me calculate the total. 6, 4, 12. There are 12 marbles in total. On the first try, the probability of getting a blue is 6 out of 12. So here's my blue. I don't have 6 anymore. I have 5. So on the second try, what's the probability of me getting a blue? Well, there's 5 blue and total of 11. So there's another blue. So that means that in the bag, now there are 4 blue marbles. What's the probability of getting a blue on the third try? Well, on the third try, if I add them up, I have 10 marbles. And how many blue are there? I have 4. And you can multiply and find your answer. So that's pretty much it. Not that complicated. So just be careful with independent and dependent. Okay?